Because I'm working for this consultancy company, Ignotech, and I started working at this postal delivery company a few years ago that had this system to plan and deliver newspapers. It was a very textual system, so there was not really any GIS or geographical data inside the system, nothing like that. So we try to optimize that. So the company mostly delivers newspapers. That is a picture of all the customers. There are 150,000 every day that have to get their newspapers from small little depots like that. So the actual people doing the deliveries are independent from the company. They are not actually employees. They have their own vehicles. They could as well be 3 Indian guys. One important part is also that it's not a static situation. A lot of subscribers change their subscription, so amazingly they do that a lot of the time. So the main requirement here is routing and planning, because this is actually a pretty complex logistics problem. And we didn't really know what to do about that, but maybe we should have looked at Infoware, because apparently they can do it too. Why OSM? Because we were not sure we could actually get this to a good ending. So it was not really an option to buy a lot of expensive data and just go on an experiment and then say we just can't do it. So experimentation, and then also, of course, the community supporting in tools and everything we actually needed to do this. Let's go to the actual requirements. So there are delivery rounds per deliver. So this is an example, a small round. I'm not sure if you can see the small boxes representing the subscribers. So basically what we need to do is this. We need to give them a route to drive on as efficiently as possible. A second requirement is this, a little more complex. When we have a new customer or a new newspaper, a lot of customers are added, and we just cannot keep using the old delivery routes. We have to optimize to get new routes and to try to divide all the customers in efficient delivery routes that are not too small but also not too big. So we also have to support different vehicle types, because some of them have cars, but there are also motorcycles and things like that. We have to support construction works. I'm not sure that's specific to Belgium, but there are everywhere construction works all the time. So we have to implement this. And we have to, of course, have clear routing instructions, because the people actually doing the deliveries are not very technical people, so we have to be really clear about what they have to do and what newspaper goes in what box and so on. And we also have to have, of course, real usable routing results. That also means implementing routing restrictions. And in Belgium there are actually quite a lot. So our solution is mapping, of course, thanks to you guys as well. And then the second part, routing. And then the third part is the optimization of the routes. And I think if I can relate to the previous presentation, the routing part will calculate the distance matrix of all the customers. The optimization part will put them in the correct order. So first, mapping. It's a small picture of my colleague actually doing some mapping. And this is feedback we get from an actual deliverer, somebody who goes out and delivers newspapers. We print a map for them sometimes, and they just, some of them have been doing this for years, so they just put house numbers and every other thing they know on the map, and we try to import it into OpenStreetMap as good as we can. It's not always perfect. So routing, as I said before, calculating the weight matrix. So this is a slight technical overview of what we do. Our routing engine purely works on a graph. So we have to create this graph from OpenStreetMaps. So we're lucky that OpenStreetMaps is actually already a graph, but not exactly, because there are those turning restrictions. And what this routing data interpreter will do, it will interpret turning restrictions and anything like that, and will return an adjusted graph to the routing engine so that it can construct correct routes. So this is essentially what we do. I'm not sure this is a good solution, but this is our solution. A node that has a turning restriction or turning weight, because turning right is easier than turning left, not in the UK, but at least in Belgium. They're on the wrong side of the road. So this is how we solve that problem, to have turning weights by use of the interpreter. So the optimization part is actually the more complex part, I think. This is a very known problem. A lot of you will probably know what it is. So, and it's not that easy to optimize, especially when you get to a large number of customers. The amount of permutations you can have for the customers are huge. So, so we have 3 steps to solve this problem. First, we calculate the weight matrix, like InfoWare does. We generate solutions using a best placement algorithm. These solutions are not yet optimized. And then, as a 3rd step, we optimize using a genetic algorithm. So, I can show this, actually. I have a little movie illustrating this. So this is our algorithm to calculate weight. So we start somewhere in the middle, and we expand with the routing, calculating routes from one point to all other points at the same time. So this is, of course, heavily slowed down. You will see it's calculating the weights for all 90 customers. That's 8,000, over 8,000 weights. It takes a while, sorry. Yeah, and it always expands the shortest rounds first. So this is the Dijkstra algorithm. I think probably many of you will know. Okay, so now it almost completed one step. I think. Come on. Yeah, so and now it's calculating the 89 others, and it's done. That's how we calculate the weights. Sorry. How do I put it back to full screen? F5? Okay, thanks. So this part was our weight calculation. So we have an initialization step here. I also have a little movie to show this. I'm actually happy I have movies. Yeah, so what we do, we take 2 customers to start with. We just choose them randomly. And then we always choose another one and insert that and expand the route so that the increase in time or the increase in weight of the route is as small as possible. So we just keep adding customers randomly, and we get a large set of solutions, which we can then optimize using the genetic algorithm. F5. Okay, so then we use a mutation operation. That means, that means just that we change little parts of the route, just little small tiny parts, just to try to optimize the routes. It's all random. It's all maybe pretty strange, but it works. Reproduction or crossover is actually just the combination of different solutions combined into another solution, and then hopefully we get a better result. Termination occurs when we are calculating, and after a certain amount of time we don't find any more optimal routes. We just stop. So I only discuss now the simple case of planning one round. We have also this case. It's a bit harder. Well, it's a lot harder actually. We have generally two cases. We have a number of customers, and we just say we have two guys that are going to deliver it. We have to plan 2 rounds. Or we have a lot of customers, and we just want rounds with a certain amount of minimum and maximum time. Solving this problem is harder, and I don't really have time to explain. So I think there's also sorry, I'm a little nervous. I think there's also a paper on it, if you want more details, or you can ask me. Then something I'm not really sure we did okay, but I could use any advice on this, really. We were not really sure how to handle creating routing instructions, because it's actually pretty difficult. We thought we had the routes, but, well, having the routes, we can't do anything with them without the instructions. So I was reading about compilers, and I did some inspiration there, and I tried creating this architecture, but it works fairly well, but it has some limitations, I think. If anybody else has a better solution for this, I would really like to know. So how do we ensure quality of our delivery rounds? The company actually is okay with giving feedback to the OSM database. So we calculate a few metrics per delivery round that the employees of the company have to solve. So they actually have to edit OpenStreetMaps for their jobs. We have a few simple measures, like the distance to the closest street is also a pretty good measurement of the quality of OpenStreetMaps in a certain area. We have a set of addresses from a government data set. I'm not really sure this is creating a derivative work, but then the quality of the geocoding results themselves, this means that when geocoding addresses that are different, sometimes they get geocoded to the exact same coordinates. We can make an estimate of, we can be pretty sure that they're wrong. And then the percentage of unnamed streets, of course, and I guess there's a lot of future work that can be done here in this area as well. Then the actual results, we have created a fully customized and fully integrated solution. We have created this into a library. It's online, it's on SourceForge, everybody can access it, everybody can edit it as much as they like, and they should be able to reproduce the same results I did. Some concrete actual results from the field. This is what they got a few years ago. There's there are no maps, so we don't like it. This is what they get now. It's not one of our final versions, but it's a lot better than what they got before. So this is only created for people that start doing a delivery round, because many people, when doing one, they find their own best routes. Everybody has their own personality. Sometimes people even stop at the wrong end of a one-way street just to do that part. So that's very hard for us to route. So this is another example of what they used to do. They would just get a map, put a marker on it for one round, and then just take photocopies and give that to people. And now we have a system that actually does everything for them, and actually a lot more. So some future improvements, faster routing, I think that one is obvious. Adjusted map rendering means, well, to give the deliverers, sometimes working at night to deliver newspapers or early in the morning, it's very hard for them to read the maps. So we have to create high contrast maps with really clear street names, and betting people can help me with that as well. More optimization parameters, for example, some vehicles have limited weight capacity, and they just can't carry 200 newspapers, so that's also something we have to do. Usability improvements, some of the employees have real problems working with the application because it's a lot more complex than it used to be, but it also contains more features. It's a .NET application. I would like to support the Mono framework to get a more open-minded and broader support. And better time estimates. The time estimates now are based just on the raw routing data, but it has to be based on a higher level. For example, turning has to be incorporated into it, but only when there are side streets or something like that. I'm not really sure what I'm going to do there, but it's not perfect. So that's it.
So, do we have questions?
I was just I had a burning question, and then you sort of answered it toward the end of your talk, which was pretty much, you said people have their personality, and you have many people with years of experience, and I would be very interested in if you feed them a route that your algorithm has optimized, will they think you're crazy, this is a really stupid route, or do you get the feedback saying, hey, this is pretty much what I do?
Well, we have had many problems with that because we want to experiment with the results before actually using it. But it's actually meant for people doing it for the first time, and we can't really expect them to work in our experiment. So we have to really look out for that because many of those people have actually been doing this for years. And we give some of them the GPS tracer so we can see what kind of route they take. And it's a lot of the time, it's like I just said, they stop at a one-way street, and then they just do a few subscribers there, and then it's completely different. This is just a guide for new people, and actually because we work with not volunteers, but with subcontractors, there is a lot of people coming and going. So that's why this is very important for us.
How long do the calculations take?
This depends, of course, greatly on the number of customers in one delivery round. But I would say for this one, 90 customers, I would say around 5 minutes. I know maybe it's a pretty long time, I don't know. But the entire optimization you saw before, that can take up to a few hours and even days when we take a lot of subscribers. So, but it works for us fine today. Maybe there are some improvements we can make, but well.
Okay, thank you, Ben.